So in this video we are going to solve question number 13.3. The question says a given coin has a mass of 3 gram. Calculate the nuclear energy that would be required to separate all the neutrons and protons from each other. For simplicity, assume that the coin is entirely made of Cu 63 atoms of mass 62.92960 U, means the mass of its nucleus, right? So for solving this you have to keep the steps in mind. The steps follows like, so first of all you have to find the mass defect on Cu nucleus, right? For Cu atom, what is the mass defect in it? Then you have to convert that mass defect in binding energy, second step. Then you have to find, you have calculated the binding energy for one Cu atom, right? So now you have to calculate how many Cu atoms present in 3 gram of coin, right? And then you have to multiply the number of atoms that are present in that coin into the binding energy for one Cu atom, right? So that is the thing that you have to do. Now let's start with the step 1. So first of all, calculate the mass defect of one Cu nuclei. So for, the formula that we have for mass defect is GMP plus A minus G Mn summation and minus of mass of nuclei, Nucleus nucleus, right? So now by putting the values, we know Z is you have 29, and then you have the mass of proton is 1.007825, and then the atomic mass we have is 63 minus 29, and that is going to be mass of neutron, that is 1.008665, and the summation of all this minus mass of that nucleus that is given in the question, right? So this is the thing, and now you have to solve this. So solving this will give you 29.22323 and approx, then 62.929, and then this value we will get is 34.2946, right? And after doing this summation, you are going to get the value is approx 0.592 U, right? So this is the thing, this is in atomic mass unit. Now you have to use the formula of binding energy delta M C square, and the value you are going to get is in joules, right? So here you have to put that by the mass defect and into 931.5, and by doing that you are not going to get in joule but in MeV, mega electron volt. After you are if you do this, if you don't write this formula, and if you want that answer directly in mega electron volt, not in joule, then you have to directly multiply it with 931.5, right? This is the thing. So if you want mega electron volt, do this use this formula, okay? Then after calculating this for the binding energy for one Cu atom, that is equal to 0.592 U, and that is sorry what is I am writing, it is 0.592 multiply 931.5, okay? So this value you are going to get is 555.20 mega volt, right? 55.552 mega volt, okay? Then after that you are going to get this value as for 3 gram of coin. So now you have to calculate that how many Cu atoms present in 3 gram of coin. So you have to use that molecular weight. The molecular weight of Cu is 63 gram, and you have to divide for number of moles. Moles is equal to given mass by molecular weight. Given mass is 3 gram and molecular weight is 63 gram, and that will give you the number of moles is 0.0476 moles, right? and by multiplying this number of moles with Avogadro number, that is 6.023 into 10 to the power 23, we are going to get the number of atoms. So that is N, that is number of atom, is 2.87 into 10 to the power 22 atoms of Cu is present in the coin. In that coin, this number of atoms are present, right? Now you don't have to do anything. You have to just multiply this number with the that is the binding energy per nucleon that we get. Just multiply, you have to just multiply this, right? So E total you are going to get is, you have to multiply that binding energy per nucleon into 2.87 into 10 to the power 22, and that is going to be binding energy total, that is 1.58 into 10 to the power 23 mega electron volt, right? So this is your answer. Okay, this is your answer.